innovation that meets the consumer-driven future head on. And this will be transformative. Another thing I learned practicing medicine is that it doesn't actually matter if you have all the right information or even the best tools if you haven't first established a solid foundation of trust. Health moves at the speed of trust. Google works to establish that trust with our users by not only building products that are safe and effective, we also design products with our core values in mind: equity, ethics, security, and privacy. We firmly believe that when Google partners with consumers, caregivers, and communities, we can democratize access to health, and together we can solve the world's biggest health challenges. So that brings me to today and this opportunity to show you how we're helping billions of people with healthier lives. As an AI-first company, we're applying our advanced technologies to go from early research to practical clinical reality. You'll see what new possibilities lie ahead with AI, including large language models. We'll provide updates on how we're creating useful, actionable information to connect people to the right care. And we'll show you how sensors and devices you use every day are making insights more personal. You'll hear how we're applying our technology to respond to one of the biggest threats to the public's health: climate change. Our partners and YouTube creators will share how they're using our tools and technology to enable future-proof health knowledge. So let's get to it. To kick us off, let me hand it over to Yossi, who will talk about the transformative potential of AI in health. Yossi?
Thanks, Karen. Hello, everyone. I'm Yossi, and I lead impact-driven research at Google. For over 16 years, I've been developing advanced technologies and AI solutions, as well as products that touch billions of people. AI is advancing at an unprecedented pace. It is a revolutionary technology that I believe will benefit almost every sector of society. And nowhere is the opportunity to help people around the world greater than in healthcare, where AI can have a transformative impact. Moving from research to clinical reality often takes years. And now we're seeing the impact of our breakthrough research, which is empowering healthcare professionals across medical fields, such as tuberculosis, various cancers, and eye diseases. Take, for example, diabetic retinopathy, which can cause blindness in diabetic patients if left untreated. Early diagnosis is vital. A seminal paper from our Health AI team, published in 2016, led to ARDA. ARDA stands for Automated Retinal Disease Assessment and is a screening tool to detect diabetic retinopathy. I've seen firsthand the impact of our research into diagnostics once it is ready for use in the clinic. When I was in Thailand last December, it was really inspiring to see ARDA in action and to speak to the healthcare workers using it. They are now able to screen 40 patients in just an hour. A patient sits in front of an AI-powered camera and receives the results in less than 2 minutes. The use of AI is helping prevent blindness with over 200,000 patients already screened worldwide. Today, you'll hear about even more ways we're using AI to help in healthcare. First, let's hear about a new line of research that I'm really excited about: recent advances in large language models and the potential medical applications. Alan.
Thank you, Yossi. Hi, I'm Alan, and I lead a research team exploring AI's potential for improving healthcare. Over the past 5 years at Google Health, our research has shown that AI can augment a clinician's ability to detect breast cancer. It can help people better understand their skin conditions, and it can help researchers sequence genomes more accurately than ever. Today, we're publishing research in JAMA Network Open on how AI can uncover brand new medical knowledge. Here, our AI research revealed a tissue morphology feature that predicts the survival of patients with colorectal cancer. And clinicians in this research use this feature to derive new insights for their patients. Our work in this field has taught us that AI on its own cannot solve all of healthcare's problems. Medicine, after all, is about caring for people. Data and algorithms must be combined with language and interaction, empathy and compassion. Data and algorithms must be combined with language and interaction, empathy and compassion. What makes us healthy is complicated. It's specific to geography and it's influenced by social drivers. We believe it is imperative to actively work to include diverse experiences, perspectives, and expertise when you're building AI systems. To bring this vision forward, we're exploring how AI models in medicine can use language and interactivity to be more effective, more helpful, and safer. Late last year, we took our first step towards rethinking conversational AI systems in medicine with MedPalm, a large language model designed to provide high-quality and authoritative answers to medical questions. We built MedPalm by instruction prompt tuning Palm. Palm is a 540 billion parameter large language model from Google Research. We did this work with a small set of carefully curated medical expert demonstrations. In multiple choice questions used for US medical licensing exams, the pass mark for new doctors is often around 60%. These questions have long been considered a grand challenge for AI systems. They require a clinician to recall medical knowledge and apply logic to identify the correct answer. Despite years of effort from leading AI labs around the world, performance on challenging tasks like this has plateaued at around 50%. Last December, our model, MedPalm, was the first AI system to exceed the pass mark. We reached a performance of over 67% on these licensing exam-style questions. We also carefully examined how MedPalm performed in many other kinds of medical question-answering tasks. These ranged from commonly asked internet search questions to complicated questions about medical research. In doing this work, we compared MedPalm's answers with answers from real clinicians, and we looked at several aspects like factual accuracy, bias, and the potential for harm. You can see one common question here, and how MedPalm answers this question, which is about incontinence. In this case, MedPalm's answer is generally sound, but it's not as comprehensive as the answer given by the clinician. The clinician here names multiple specific causes of incontinence, as you can see, where MedPalm is less comprehensive. And doctors rating this answer from MedPalm agreed they found it generally accurate and safe, but you can see here that they highlighted that there's room for improvement in the level of detail our system provided. You can see from this sort of work that we're still learning. One interesting aspect of this kind of work is that the evaluating physician's rating of this answer may also change depending on their own clinical expertise and their experience in this subject area. In this next example, MedPalm's answer is complementary to the clinician's. MedPalm mentions similar information, but in different ways, and it makes this lovely point about how the severity of symptoms can vary depending on the type of pneumonia and the overall health of the person. Doctors rated this answer as very high quality across our rating framework. We believe it's really important to innovate responsibly by doing this kind of rigorous research in healthcare. Today, we're announcing results from MedPalm 2, our new and improved model. MedPalm 2 has reached 85% accuracy on the medical exam benchmark in research. This performance is on par with expert test takers. It far exceeds the passing score, and it's an 18% leap over our own state-of-art results from MedPalm. MedPalm 2 also performed impressively on Indian medical exams, and it's the first AI system to exceed the passing score on those challenging questions. There are many ways that an AI system like MedPalm can be a building block for advanced natural language processing in healthcare, and we'd like to work with researchers and experts to advance this work. The potential here is tremendous, but it's crucial that real-world applications are explored in a responsible and ethical manner. And as we do that, we're looking forward to sharing our progress with you at a future checkup. Next, Greg, who leads our health AI efforts, is going to share how we're working with partners. everyone, I'm Greg, and I lead Health AI at Google. In a world where it feels like we're making the impossible possible, it's so important to take a beat and evaluate whether we're building the right tools for the right people in the right way. Today, I want to talk to you about how we're using partnership to do just that. At Google Health, we work with partners both to validate and improve our technology and to go beyond research to drive real-world impact. First, let's talk about ultrasound. Ultrasound is a radiation-free, versatile, and increasingly more accessible early disease detection tool. It can provide real-time dynamic views of fetuses, hearts, lungs, and more. You're probably familiar with big ultrasound machines in hospitals. But in recent years, sensor technology has evolved to make ultrasound devices significantly more portable and more affordable, with many handheld devices available today for a fraction of the price. In most cases, experts, who often train for years, are required to conduct the ultrasound exam and interpret the images. But in many lower resource settings, we have a shortage of such specialists. This is an area where AI can help. In collaboration with global research teams, we have built AI models to interpret ultrasound images and identified important information, like gestational age. This can help non-experts acquire and interpret ultrasound images to triage high-risk patients simply by sweeping the handheld probe across mom's belly. Although our research has shown that AI models could do these things, that doesn't necessarily mean that AI would work in the communities that we are most interested in impacting. For that to happen, it's critical that we work with local partners, adapting our technology to real-world conditions. Today, we're thrilled to announce 2 new research partnerships to help improve our ultrasound AI technology. We're working with Changgang Memorial Hospital, or CGMH, in Taiwan for breast ultrasound, and Jacaranda Health in Kenya for maternal health ultrasound. We chose these 2 regions and partners to ensure that our technology works for the